Okay, so the next question that we have is question number 12, which is the ratio of the sums of n, m, and n terms of an AP is m squared to n squared. Show that the ratio of the mth and nth term is 2m minus 1 to 2n plus 1. So you have basically the ratio of the sums of m and n terms of an AP, s of m to s of n is equal to m squared by n squared. You want to show that the ratio of the mth and nth term, meaning that a of m to a of n, is equal to 2m minus 1 to 2n minus 1. 2m minus 1 to 2n minus 1. So let me see how they have solved this problem. Okay, so as the solution, we can assume that we have to make some assumptions. So let A and D be the first term, and the common difference of the AP of the arithmetic progression respectively. According to the given condition, we have basically s of m to s of n is equal to m squared to n squared. So s of m to s of n is equal to m squared to n squared, right? And that means that basically, since you know that s of n is equal to n divided by 2 times 2a plus n minus 1 times d, that means that s of m would be equal to m divided by 2 times 2 times a plus m minus 1 times d, and s of n therefore would be n divided by 2 times 2a plus n minus 1 times d, and that is equal to m squared by n squared. And so you can cancel out the 2's in the denominators, and you can cancel and 1m over here to 1m over here, and 1n over here to 1n over here, and therefore you have 2a plus m minus 1 times d over 2a plus n minus 1 times d is equal to m divided by n. So you can call this equation number 1. Now if you put m is equal to 2m minus 1 and n is equal to 2n minus 1, so let me see. Okay, so now if you put m is equal to 2m minus 1 and basically n is equal to 2n minus 1, I'm keeping the same ratio here. So since I'm keeping the same ratio, I'm allowed to do this. Otherwise, you wouldn't be able to do this if you set for example m is equal to 2m and for example n is equal to, for example, 3n, for example. That doesn't work. But as long as you keep the ratio, you have no problem. You can actually do that. So that means that basically you can write basically in 1 we have we have basically m becomes 2m minus 1, n becomes 2n minus 1, so you have 2a plus basically m becomes 2m minus 1, 2m minus 1, and again minus 1, so that becomes 2m minus 2, and so over here you have 2m minus 2 times d, and in the denominator you have 2a n minus 1 would be 2n minus 1 minus 1, which is equal to 2n minus 2 plus 2n minus 2 times d is equal to basically m becomes 2m minus 1 and n becomes 2n minus 1. And so you can take a, from here, what you can do is that you can take a 2 out from here, meaning that you can write basically 2a plus 2 times m minus 1 times d, and then divide that by basically 2a plus 2 times n minus 1 times d is equal to basically 2m minus 1 over 2n minus 1. And then from here you can write basically 2 times a plus m minus 1 times d divided by 2 times a plus n minus 1 times d is equal to basically 2m minus 1, divide that by 2n minus 1, and then you can cancel these two out, and since a of n is equal to a plus n minus 1 times d, therefore you can write this as a of m, and you can write this as a of n, and a of m to a of n is equal to 2m minus 1 to 2n minus 1. And that's what we wanted to show here, right? So that is basically question number 12. So question number 13, we have if the sum of n terms of an AP is 3n squared plus 5n and its mth term is 164, find the value of m. So number 13 is basically the sum of n terms of an AP is s of n is equal to 3 times n squared plus 5 times n, and the mth term is 164. A of m is equal to 164. Find the value of m. Okay, so now to solve this problem, this is actually a typical problem and a good problem that you can learn a lot from. Meaning that I actually had to solve the problem for myself once, so let me erase all of these and then we will do that again. Okay, so basically, as we have always done, almost always, you have to make some assumptions, right? So the assumption that you make here is that, so you can assume that, for example, A and D, so you can say that let, for example, A and D are the first terms, and the first term and the common difference of the basically arithmetic progression respectively. respectively. So basically a of m, since basically a of n is equal to a plus n minus 1 times d. Therefore a of m is equal to a plus n minus 1 times d. You can call it, for example, equation number 1. We will use that later. Now the sum of n terms would be s of n is equal to n divided by 2 times 2a plus n minus 1 times d, and that is equal to by the information that we have is equal to 3 times n squared plus 5 times n, right? Now if you do this multiplication here, this is actually an interesting way that you can find information about basically in algebra, and it is actually a valid way to find, for example, the values of a and d using this type of equation, meaning that you have n divided by 2 times 2a plus n minus 1 times d is equal to 3 times n squared plus 5 times n. And then what you can do is that you need to, since you know that this expression is equal to this expression, you need to somehow find some way in order to rewrite the left hand side of the equation in such a way that it looks like it looks like the right hand side, meaning that you have n squared and some coefficient here plus n and some coefficient here. And then if you can get this side of the equation to look like this, then you can just simply compare and say that, for example, the coefficient of n squared on this side is equal to the coefficient of n squared on the other side, and the coefficient of n on this side is equal to the coefficient of n on the other side, and that way you will be able to find a and d, right? So long story short, you can here write basically n divided by 2 times 2a plus, basically multiply this, you'll get nd minus d, and so basically you will have n divided by 2 times 2a plus n divided by 2 times nd minus n divided by 2 times d, and that is equal to of course 3n squared plus 5n, 3n squared plus 5n. And then you can multiply these out, so 2 and 2 you can cancel out, you'll get na plus n times n squared times d divided by 2 minus n times d divided by 2, right? That is equal to 3 times n squared plus 5 times n. Then you have to put the n's together, meaning that from this term you can take an n out and write this as a minus d divided by 2, right, plus n squared times d squared. That is equal to 3 times n squared plus 5 times n. And so as you can see, the coefficient of n here is equal to a minus d divided by 2, which is equal to 5, because it's the coefficient of n here. And the coefficient of n squared is equal to d divided by 2 here, and here is equal to 3. This gives basically d is equal to 6. So that way you can find d. And then you can use this value of d here and write this as a minus 6 divided by 2 is equal to 3, minus 3 is equal to 5, which means that a is equal to 8. So now you have the values of a and d. Now over here we said that basically we said that a of m is equal to 164, right? A of m is equal to 164. A of m is equal to 164, which means that basically a plus m minus 1 times d is equal to 164. And basically what we want to do is we want to find actually the value of m, right? So you know that your a is equal to 8, so 8 plus m minus 1, and the value of d here is equal to 6 times 6 is equal to 164. And so 8 plus 6m minus 6 is equal to 164, which means that basically 6m is equal to 164 minus 8. And let me write another step here. So I can say that 8 minus 6 is equal to 2, so 2 plus 6m is equal to 164. Take divide by 2, you will get basically 1 plus 3m is equal to 164 divided by 2 is equal to 50, 30, and 2, that's 82. Which means that 3m is equal to 82 minus 1, which is equal to 81. Which means that m is equal to 81 divided by 3, which is equal to 27. M is equal to 27. So that means that the term that we had over here, a of m, which is equal to 164, that's actually the 27th term, because m is equal to 27. That is the 27th term. That is the 27th term. Okay. Now that was question number 13. Question number 14, we have the following. Okay, so question number 14 is basically you want to insert 5 numbers between 8 and 26. Insert 5 numbers between 8 and 26, such that the resulting sequence is an AP. Okay, so if you want to insert 5 numbers between 8 and 26, so basically, yeah, the formula that you had that we developed for this kind of situation was that first of all you need to calculate your D, right? Or your common difference, meaning that when you have some number A and some number B, and you want to insert n numbers between them, then what you need to do is that your D becomes basically the difference of the two numbers B minus A divided by n plus 1. And the reason why I'm saying this is that, for example, let's say that you have 2 and 8, and you want to insert, for example, 5 numbers between them, right? If you want to insert 5 numbers between these two numbers, what you can do is that there is some difference between 2 and 8, right? Which is basically 8 minus 2. And this distance has to be divided into 6 equal distances, so that then you can insert 5 numbers between them. So I repeat that this distance has to be basically divided into 6 equal distances so that you can insert 5 numbers between them. So one more than the number of the numbers that you want to insert. Which means that I have to divide this distance by 6. So that is basically b minus a divided by n plus 1, which is the number of numbers that you want to insert, right? So and then based on that you can say that so there you have basically 6 divided by 6, which is equal to 1. That means that each equal distance is actually 1 unit, right? So then if you start from 2, so then this is simply your d, your common difference. So added to 2, you'll get 3, you'll get 4, you'll get basically, you'll get 5, you'll get 6, you'll get 7, and you'll get 8. These are the numbers that you started with, and these are the 5 numbers that you wanted to insert. And you can basically think of this situation in the following way as well, meaning that suppose that you want to insert A1, A2, A3, A4, and A5 between these numbers. Then essentially you can say that A1 is the same thing as A plus n times d. A plus n times d, meaning that, A1 is equal to basically, you can basically say that A1, which is this number over here, is the same thing as this number 2 plus basically the common difference, which is 1, times which is basically the number of the term, which is 1, times the common difference, which is 1, right? So that becomes basically 2 plus 1 is equal to 3, which is the number over here. The second term, 4, the second term a of 2, again is equal to the first number plus the number of the term, which is 2, times the common difference, which is 1, which is equal to 2 plus 2, which is equal to 4. As you can see, you're getting this over here. And you can say that a of 3 is equal to, again, 2, the first number, a, plus the number of the term, which is equal to 3 times the common difference. And that is equal to 2 plus 3 is equal to 5. And as you can see, you get this number over here, and so on and so forth. Which means that your a of n is actually equal to a plus n times d. The first number plus the number of the term times the common difference, right? Which means that you can say a of n is equal to a plus nd, and then you can use these two formulas in order to basically find the numbers that you're looking for. But then again, you have to be careful here, meaning that this n over here is actually not the same thing as this n over here. This n over here refers to the number of terms that you have. For example, you have A1, you have A2, you have A3, and so on and so forth. So this n basically refers to this index over here. But this n over here refers to actually the number of terms that you want to insert between a and b. Right? So that there you have to be clear about that. And if we understand that much clearly, so that basically means that then to calculate your d here, you can write basically b minus a, which is equal to 26 minus 8 divided by the number of terms that you want to insert. So 5 plus 1 is equal to 6. Which is equal to basically 26 minus 8 is equal to 18 divided by 6, which is equal to 3. So your d is equal to 3. And now you can calculate the 5 numbers that you're looking for, meaning that you have your a1, a plus n times d, so your a is equal to basically 8 plus 1 times d, which is equal to 3. So that's 8 plus 3, which is equal to 11. A of 2 is equal to basically 8 plus 2 times 3, which is equal to 8 plus 6, which is equal to 14. A of 3 is equal to 8 plus 3 times 3, which is equal to 9 plus 8 is equal to 17. A of 4 is equal to 8 plus 4 times 3, which is equal to 12 plus 8, which is equal to 20. And A of 5 is equal to 8 plus 5 times 3, which is equal to 15 plus 8 is equal to 23. And so these are the numbers that we want to insert between 8 and 26. Now we have 8 and 26 in the end, and then after 8 I have 11, I have 14, I have 17, I have 20, I have 23 and 26 in the end. And that means that basically the numbers that you were looking for are basically, these are the numbers that you started with, and these 5 numbers are the numbers that you inserted between them, and the difference between each two successive terms, or each two consecutive terms, are actually the same. 3, 3, 3, 3, 3, and 3. So that's basically how you solve this kind of problem. Okay, so that was basically question number 14. Now question number 15 is, okay, so the next question that we have is question number 15, which is, if a raised to the power n plus b raised to the power n over a raised to the power n minus 1 plus b raised to the power n minus 1 is equal to, is the arithmetic mean between a and b, then find the value of n. And find the value of n. So if basically this term is the arithmetic mean between a and b, what that means is that you can imagine that you have, for example, 3 terms, a, for example, c and b, and c is basically this term over here, and this forms an arithmetic progression. Since this basically forms an arithmetic progression, you know that in an arithmetic progression you can always write 2 times c is equal to a plus b, right? Which means that you can write basically the arithmetic mean of the 2 terms, which means that you can write basically the arithmetic mean of the 2 terms, meaning a raised to the power n plus b raised to the power n. Divide that by a raised to the power n minus 1 plus b raised to the power n minus 1. That is equal to a plus b. Or you can simply say that, for example, actually 2 times this, so 2 times this is equal to a plus b. Or you can say that basically this term is equal to this term plus this term divided by 2. That you can say as well, of course. Meaning that, for example, if you have 2 numbers, for example, 2 and 8, the average of these 2 numbers would be 8 plus 2 divided by 2, right? And this is also the average of these 2 numbers, a and b, and therefore it is equal to, and then you can write this as this whole expression, a raised to the power n plus b raised to the power n over a raised to the power n minus 1 plus b raised to the power n minus 1. And divide this by 2, divide this also by 2, you will get a plus b raised to the power, basically divided by 2, right? So that means that this is actually the average of a and b, or the arithmetic mean of a and b, basically the same thing. So what that means is that then you can say that you can write this expression, and the value of a raised to the power n plus b raised to the power n over a raised to the power n minus 1 plus b raised to the power n minus 1, you can use basically the, I don't know if you have done I mean, at this point in this book, whether we have done the binomial theorem or not. But using the binomial theorem, for example, I don't know where we are actually here. We are at class 11, chapter 9. We have actually done the binomial theorem. This is class 11, chapter 9. So class 11, chapter 8, we have actually done the binomial theorem. So we can use it here, and so you basically know that a raised to the power n plus b raised to the power n. You know that a raised to the power n, a plus b raised to the power n is just simply equal to n combination 0 a raised to the power n plus n combination 1 a raised to the power n minus 1 b times b plus n combination 2 a raised to the power n minus 2 times b squared plus all the way up to n combination n b raised to the power n, right? So that means that basically n combination 0 is equal to 1, right? That is actually equal to 1, because you have n objects, you're discarding everything. There is only one way to do that, so that would be equal to 1. Or you can think of this as n combination 0 is equal to n factorial over n factorial times 0 factorial, which is equal to 1. N combination n is also equal to n factorial 0 factorial n factorial, which is also equal to 1. Which means that these two terms, you can actually write them as a raised to the power n and b raised to the power n. And that basically means that you can write this as basically a raised to the power n plus b raised to the power n. You can write it as basically a plus b raised to the power n minus all of these terms. So that means that a raised to the power n plus b raised to the power n, you can write it as a plus b raised to the power whole raised to the power n minus all of these terms over here, right? But I'm not really sure how helpful that would be. So let me see if we can, let me take a look at the solution. No, actually they haven't even used the binomial theorem here. So they have written this as basically divide by 2. You will get a raised to the power n plus b raised to the power n divided by a raised to the power n minus 1 plus b raised to the power n minus 1. And they have written it as basically a plus b divided by 2. And then you can you can say that basically a plus b times cross multiply simply a raised to the power n minus 1 plus b raised to the power n minus 1 times a plus b is equal to 2 times a raised to the power n plus b raised to the power n. Which is going to give you a raised to the power n plus a times b raised to the power n minus 1 plus a plus b times a raised to the power n minus 1 plus b raised to the power n is equal to 2 times a raised to the power n plus 2 times b raised to the power n. And so you can cancel out basically well, you can write this as basically a raised to, so you can bring these two terms to the other side of the equation. A times b raised to the power n minus 1 plus b times a raised to the power n minus 1 is equal to 2 times a raised to the power n plus 2 times b raised to the power n minus a raised to the power n minus b raised to the power n. And therefore you can write this as ab raised to the power n minus 1 plus ba raised to the power n minus 1 is equal to a raised to the power n plus b raised to the power n. And you can then, what you can do is that you can take you can basically from so what you can do is that, so here you have basically a times, so over here let's review this one more time. So you have a raised to the power n minus 1 plus b raised to the power n minus times a plus b is equal to 2 times a raised to the power n plus b raised to the power n. So, and then over here you can multiply a raised to the power n minus 1 times a is equal to 8 raised to the power n, which is this term over here. And then this term times this would be a raised to the power n minus 1 times b, a raised to the power n minus 1 times b. Okay, so what you can do here now is that, well, you need to basically, for example, keep this on the right hand side of the equation, and here you have b raised to the power n minus 1, so I write this as 8 times b raised to the power n minus 1, and I take this to the other side, minus b raised to the power n, and I write over here a raised to the power n minus b times a raised to the power n minus 1, right? So from here I can take a b raised to the power n minus 1 out and write this as a minus b, because b raised to the power n minus 1 times b is equal to b raised to the power n minus 1 plus 1 n minus 1 plus 1 n minus 1 plus 1, which is equal to b raised to the power n, right? So b raised to the power n minus 1 times b is equal to b raised to the power n. And so then over here you can take a raised to the power n minus 1 out and write this as a, because then you would get a raised to the power n minus b, right? So then what you can do here is that you can simplify a minus b and a minus b, and so you have, for example, you can write this as divide both sides by b raised to the power n minus 1. You'll get the 1 here, and a raised to the power n minus 1 over b raised to the power n minus 1. And that's the same thing as a divided by b whole raised to the power n minus 1. And since this is equal to 1, you can write it as you can write it as a divided by b raised to the power 0, because anything raised to the power 0 is equal to 1, right? Which implies that basically, now since these two are equal and a divided by b is equal to a divided by b, you can say that n minus 1 is equal to 0, and therefore n is equal to 1. And so what that means is that basically then your n is equal to 1 here. Okay, so the next question that we have, is question number 16. Question number 16, which is basically between 1 and 31, m numbers have been inserted in such a way that the resulting sequence is an AP, and the ratio of the 7th and m minus 1th terms, or numbers, is 5 by 9. Find the value of m. So you have between basically number 16, you have between 1 and 31, m numbers have been inserted in such a way that the resulting sequence is an AP, and the ratio of the the 7th and m minus 1th there, 7th and m minus 1th terms, m minus 1th terms are, or is basically 5 to 9. Find the value of m. Okay, so now I think I made a mistake here. So what I will do is that I will erase all of this, and then we will do this one more time together. So basically, the way that you can solve this problem, we have actually solved this type of problem before. So I hope that you already know about how to find the common difference and the terms and so on and so forth. But to refresh your memory, or to strengthen your understanding. So basically, when you have these numbers 1 to 31, so when you have basically, we said that if you have two numbers, let's say that you have two numbers a and b, and let's say that, for example, n numbers have been inserted between a and b, and well, in such a way that you're left with an arithmetic progression. The sequence is an arithmetic progression. Then in that case, basically the way that you can find those numbers, those terms, would be a1 and a2 and a3 and so on and so forth, all the way up to a of n. And a of n in this case is equal to a plus n times d, right? in this particular case, a of n is equal to a plus n times d, and this is capital A of n, not just a of n this way, right? And then the common difference, we said that the common difference is equal to d is equal to b minus a times n minus n plus 1, and here n refers to the number of those the number of numbers that have been inserted between a and b, meaning that this n refers to something else than this n. So I hope that you already, I mean, you can remember that much from the previous exercises. And so if that is the case, so let's if that's not the case, then you can go back to the exercise where we actually discussed all of this to learn that. It's probably in the same video. And if you already understand this, so let's start solving this problem. So we have basically the numbers that we have are 1 and 31, and m numbers have been inserted in such a way that the resulting sequence is an arithmetic progression, which means that basically you can calculate your d by basically writing b minus a divided by n plus 1. Now in this formula, b is the second number, which is 31 in this case, minus a, which is basically the first number, and n is basically the number of numbers that have been inserted. So m numbers have been inserted, so you would get m plus 1. So that is your common difference, or d, right? So since your common difference is we have already found the common difference, now basically the second piece of information that we have is that the ratio of the seventh term and the n minus 1th term is 5 to 9. Now this seventh term and the n minus 1th term is not the same thing as the seventh term of an AP in the usual case, meaning that usually what you do is that you write a of 7 is equal to a plus n minus 1, or you simply say that a of n is equal to a plus n minus 1 times d, and based on this formula, a of 7 would be basically a plus 6 times d, right? But this would not work here, because these are the terms between these two terms that have been inserted. And so in this case, to calculate those, for example, the seventh term, you have to calculate the capital A of, so in this case, you have to calculate capital A of n, which is equal to a plus basically nd, right? So which means that basically, for example, a of 7 in this case would be a, which is this first number here, a plus n times, and n refers to just this index here, right? This index here, a plus 7 times d, right? And so what that means is that, for example, a of 7 in this case would be 1 plus 7 times d, and 7 times d would be, so this if I were to simplify this, I would write this as 31 minus 1 is equal to 30 over n plus 1 over n plus 1, and so that's 7 times 30 is equal to 210, is equal to 210 by n plus 1. And so that's the same thing as, for example, n plus 1, and n plus 1 plus 210, and that's the same thing as basically m plus 211 divided by m plus 1. That is a of 7. Now, by the same logic, a of m minus 1, the m minus 1th term, a of basically m minus 1 would be equal to a plus m minus 1 times d, which is equal to a, which is equal to 1 plus m minus 1 times d, or d is equal to basically 30 over m plus 1. So I have to write here m minus 1 times 30 divided by m plus 1, which is the same thing as basically m plus 1 and m plus 1 plus, well, 30, that's the same thing as 30 m minus 30. So 30 m minus 30, and that gives you basically 30 m plus m is 31m. 30 m plus m is equal to 31 minus 29. Negative 30 plus 1 is equal to negative 29 over m plus 1. That is a of m minus 1. Right? So that's the 7th term here, and that is the m minus 1th term. So I can write a of 7 to a of m minus 1 is equal to basically m plus 211 over m plus 1, and you have to divide that by, of course, 31m minus 29 over m plus 1, and that I have to write down here. That is the same thing as a of 7 over a of m minus 1, right? So I can cancel these two out and write this as basically m plus 211 over 31m minus 29, right? Now this ratio is 5 to 9. This ratio is 5 to 9. So what this means is that then you can cross multiply, meaning that you can write 9 times m plus 211 is equal to 5 times 31m minus 29, and that would be the same thing as 9m plus 9 times 211 is equal to 211 times 9 is equal to 1899 is equal to 5 times 31 is equal to 5, and 155m minus 29 times 5 is equal to 5 times is equal to 45, 145. So 9m minus 155m is equal to negative 145 minus 1899. And what is 155 minus 9 is the same thing as negative 146. Negative 146m is equal to so 155 minus 9 with a negative sign. You have a 4 here, you have 15 minus 9 is equal to 6, 146, negative 146. And then 1899 plus 145 is the same thing as 9 plus 5 is equal to 14,1. That's a 14,1. 8 plus 2 is equal to 10, and 2044. And that's a negative 2044. Which means that basically you can cancel out negative and negative here, and m is equal to 2044 divided by 146. 2044 divided by 146. I would do some divisibility test here, but we don't have enough time, so I don't basically, we can't do it right now. Now, 1 times 146 is 146. So you have 1 and 10, 9 and 14. So 14 minus 6 is equal to 8, 5 and 4. And then what is 584 divided by 6? 4 times 6 is equal to 24. I think 4 times 146 times 4. 24, 2, 16, 18, 1, and 4, 584. So that's 4 times there. That's 14, right? So that is equal to 14. Which means that your m is equal to 14. Now since your m is equal to 14, you can actually calculate your term here. So your m is equal to 14, right? Now, since your m is equal to 14, what you can do is that calculate a of 7, which is m plus 211. M plus 211. So a of 7 is basically m plus 211, which is basically 14 plus 211 is 211 plus 14 is 225. 225 and 31 m minus 29. 31 m minus 29. What is 31 times 14? 4 and 12, 0, 31. So you have 4 and 3 and 4, 434. 434, subtract 29 from it, you will get a 2 here, a 14 here. 5 plus 9 is equal to 14, 0, 405. 405. So that's a of basically, that is a of m minus 1 is equal to, which is m of a of basically 13. That is basically 400. That is basically 405. 405. So if you take the ratio of these two, a of 7 and a of basically m minus 1, what you will get is 225 by 405. Let me do this quickly using the calculator. 225 divided by 405 is exactly 5/9. That is exactly 5/9. So that was basically question number 16. Now the next thing that we have is question number 17 and 18. So I'll see you in the next video with these two questions. Thank you.